Greetings, junior scientists, and citizens of the great big weird wild and wonderful world in which we live. As always, I'm your humble science communicator, the Great Orbex, coming to you from the Department of Physics here at the University of Guelph. I'd like to welcome you to our March 2025 Stargazing Guide. Well, as we start to poke our heads out from underneath this blanket of snow we've been under, we see a thaw on the horizon. And while it may be hard to believe, we've made it through yet another winter, junior scientists. So what do our March skies hold for the astro-curious, young and old? This month, we look for the crab in the zodiac. Our worm moon turns blood red during a total lunar eclipse. And we learn what the first day of spring really means. All of this and more when we take some time to look up. We've spoken about the constellations of the zodiac a few times before. The zodiac is a region of space along the ecliptic divided into 12 equal parts, more or less aligning with 12 different constellations. This month, I want you to make a point to see if you can spot Cancer. In Greek mythology, a crab tried to stop Heracles from slaying the Hydra, and was quickly dealt with after biting Heracles on the toe. Hera felt that the crab deserved a place amongst the stars for that toe bite, and so goes the legend of Cancer. Cancer is actually the dimmest of the zodiacal constellations, with Gemini to the west, Leo to the east, and bordered above and below by Lynx and Hydra. Now, while dim, Cancer contains an open star cluster known as the Beehive Cluster, or M44. And even though the Beehive Cluster is nearly 600 light years away, you can still see it with the unaided eye, where it'll appear as a fuzzy white region of space. Better yet, try to get some binoculars or a telescope for better resolution. March is the perfect time to try and spot this deep sky object, so good luck, junior scientists. Our full moon this month takes place in the early hours of the morning of March 14th and is known as the worm moon. As we approach the first day of spring, the ground begins to thaw and our annelid friends make their way towards the surface, providing food for the returning birds, notably the majestic eagle, for which the Cree named the March moon Mikkisuipism. Closer to our own stomachs, other First Nations connect this moon with the running tree sap, with the Mi'kmaq calling it the maple sugar moon, Suikewi goose, and the Ojibwe of the Great Lakes region calling the sugar moon Zizbakdogegizis. Actually, this month we not only have a full worm moon, but we have a full worm blood moon. That's right, a total lunar eclipse will take place in the early morning hours of March 14th, Pi Day. The last time we saw a total lunar eclipse was in November of 2023. That's right, a full lunar eclipse will be taking place in the early morning hours of November 8th. And as it turns out, it'll be the last full lunar eclipse that we'll be able to see until March 14th, 2025. Pi Day 2025. And we won't see another until March again of next year. So what exactly is a lunar eclipse? Now, you're likely familiar with a solar eclipse like the one we saw in April of 2024. A solar eclipse occurs when the moon passes between the Earth and the sun. Well, a lunar eclipse occurs when the moon actually falls into the Earth's shadow. But the moon appears to move between the sun and the Earth during new moon, and is opposite the Earth and the sun during the full moon. So why don't we have eclipses twice a month then? Well, it's actually a little bit more complicated than that. The plane of the moon's orbit around the Earth is actually tipped at 5 degrees with respect to the Earth's orbit around the sun. This means that even though we have a full moon, the moon doesn't always line up in the Earth's shadow. But at least twice a year it does. And that's when we experience a lunar eclipse. So then what's the deal with it turning red and calling it a blood moon? The Earth's shadow has two distinct parts. When the moon passes into the Earth's penumbra, this faint shadow darkens the moon slightly. When it passes into the umbra, the moon will briefly completely darken and then turn red. At this point, we have a total lunar eclipse. But why red? As the sun's light passes through the Earth's atmosphere, it scatters. This results in shorter wavelengths like blue light being diverted away from the moon, whereas the longer wavelengths like red light are what bathe the moon. As a matter of fact, if you happen to be standing on the moon during the lunar eclipse, you'd see a red ring emanating around the Earth, which is all that remains of the light escaping Earth's atmosphere, of all the sunrises and sunsets taking place on the edge of the Earth. Now, unlike a solar eclipse, it's perfectly safe to look at a lunar eclipse with the unaided eye, binoculars, or even a telescope. Here at the University of Guelph and in most of North America, we'll be able to see the lunar eclipse in its entirety. The moon will enter into the Earth's penumbra at approximately midnight on the evening of March 13th, going into the morning of the 14th. The total eclipse, when it enters into the penumbra and then starts to turn red, will start around 2:30 a.m., reach totality by 3 a.m., and leave the umbra around 3:30 a.m., returning to the penumbral phase and eventually returning to a normal full moon around 6 a.m. until it sets at about 7:45 in the morning. Now, only a few days later, on March 20th, will be the vernal equinox, or what's commonly denoted as the first day of spring. So this month, we'll see the first day of spring, and here's why. We all remember that the Earth is tilted at 23.5 degrees with respect to the line that's perpendicular to the plane of our orbit around the Sun. 1 Earth year corresponds to 1 full solar orbit. Back in December, we talked about the winter solstice, the one day each year when the North Pole is tipped its furthest distance away from the Sun, resulting in the fewest daylight hours experienced in the year for us here in the Northern Hemisphere. Conversely, the summer solstice marks the day when the North Pole is tipped towards the Sun, resulting in the most daylight hours we experience in a year. On Thursday, March 20th, is the vernal equinox. On this day, halfway between the winter and the summer solstice, we experience equal amounts of daylight and nighttime hours. And in North America, this denotes the first day of spring. This phenomenon occurs again in 6 months when we've passed 180 degrees through our orbit around the Sun. We call this the autumnal equinox, and it takes place this year on September 22nd, denoting the first day of autumn. What do you know? Wow, what a jam-packed month, junior scientists. I wish you luck and nothing but clear skies in your astro journey as you take some time to look up. And daylight savings time begins on March 9th. See you next month, junior scientists, and don't forget to have a science-tastic day. Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help preparing our stargazing guide. And the Royal Astronomical Society of Canada